Welcome to Pepperl+Fuchs Plugged In, where automation professionals can stay in touch with the latest enhancements in sensing, data communication, and control.
Hello, and welcome everybody to today's episode of Pepperl+Fuchs Plugged In. Today I have Theo Woodson here. He's a product manager for cables and cordsets at P&F. Hello, Theo. How are you?
Hi, Helga. I'm doing great. How are you?
Very good. Theo, today you have we went through this a little bit ahead of the interview, but an awesome list of things regarding cables, specifically terms that are common or maybe not so common that have to do with connectors.
Right. So, we all hear about these things all the time, but there are some common terms and also some uncommon terms that you may not know. Maybe for those new to PNF from other countries or just unfamiliar with the product group. We'll basically go over some glossary terms to make you more knowledgeable about cord sets.
And the list that you had shown me earlier is great for engineers out in the field. I mean, after all, that's what we're doing. We're trying to educate the engineers so they make better decisions. And if they don't remember, at least they can come to us and we'll give them the right answers.
Right. It's all about making people more knowledgeable. So first, we'll basically examine the anatomy of a cord from front to back, and in between and at the end, go over some other phrases and words that might stand out.
That's an excellent idea. So let's start at the working end.
Right. So the first one we have is the pin. Many people have heard that. It's also called a contact. So those are effectively the metal rods and cavities that connect the electricity between devices.
And incidentally, I may add, in our products, they are gold coated.
Yeah, that's right.
For very good reasons.
Is an excellent conductor of electricity.
And protection with regards to the environment.
Yes, and corrosion as well.
Yeah.
So the next component on the cord is the contact carrier. The contact carrier is sometimes also called a plug and socket, or maybe a head, or even a connector. And so the contact carrier is the plastic housing that holds the pins in place. It allows for the connection to be made and keeps everything right where it's supposed to be so the connection is secure.
Now, there's something pretty interesting about particularly our M12 connectors. When you look into the connector and you kind of look past the pins, you see a strange shape of that contact carrier. Talk about that.
Right. So there's a little recessed geometry that has a very specific design and purpose. And what it enhances is called the creepage distance. And for us, it's twice the industry standard. It is effectively the extra space in that geometric design that allows an increased tolerance to contamination like moisture and dirt or dust.
And it keeps electricity from creeping, thus creeping distance, from creeping from one pin, let's say the plus to the minus. Is that not correct?
Yeah, that's right. So it's at the bottom of the pin carrier is where this recessed geometry is, and it reduces the chance of pin-to-pin contact that can cause short-circuiting and thus failure of your components and your machinery.
Very good. All right, what's next?
So next we have a knurled hex nut or a coupling nut. So the knurled hex nut is the metal fastener. It's the nut used to secure the connections together.
And why knurled? What's the relevance of the knurling? And for those that don't know, what is knurling in the first place?
Right. So a lot of people haven't heard of knurling, but I'm sure they've touched it if they've ever touched one of our cables or connectors. So the knurling refers to the small ridges on the nut that make it easier to grip and tighten by hand. And an interesting feature on P&F's products are that our nuts have both knurling and a hexagonal wrench capability.
So a six-pointed wrench can be used to also tighten that down. Carefully, right. Though. Carefully.
Yes, carefully. So we have, right, so the nut itself has both the knurling tightened by hand or with the tool that we actually carry, a hex screwdriver that acts as a torque wrench to be able to torque those down in tight places or to match that spec of the torque exactly.
All right, very good. Then we have, I think, overmolding.
That's right. So many people have heard of this. It's a very common phrase, and it refers to the plastic casting that effectively secures the cable itself to the contact carrier. So the cable refers to obviously both the jacket and the conductor wire inside. The jacket is also sometimes called a sheath, and the jacket is the plastic material that covers and insulates the conductor wiring. Then the conductor wire inside of that is the twisted metal wire itself that conducts electricity through the cable.
I think, in fact, at one point in time in the future, we should have an episode on cable materials because there is so much to say about cable materials. It would be a little bit out of bounds for this episode, but it's definitely an interesting topic.
Yeah, that's very right. There's so many kinds of different materials used in all of these various components that we're measuring that all have significance and relevance in their design and application.
Excellent. Next one you have is flying leads, pigtails. What does that mean?
Right. So flying leads, as many might have heard or not, are the exposed wire and free hanging cables that extend from one end of the cord.
Okay.
So they're called pigtails because sometimes when the wires curl up at the end from old or dried out plastic or some other aspect, they sort of look like an actual pig's tail, just short little strings hanging off the end.
Okay.
So,
yep, you go ahead.
yeah,
Next one.
The next one we have is a home run cable. And so a lot of people have heard of home run cable, but it sometimes could be confusing. Customer asks, "Oh, what do you guys have any home run cable?" You might not know, or anyone might not know, because it might mean different things in different industries. So what it means is that typically a cable that comes from the original power source. And that could also mean that there are multiple signals coming from multiple places going to one place, like an IO link master or a distribution block.
Okay, it's essentially almost like a backbone cable.
Yeah, that's exactly right, a backbone cable.
Great.
So next we have an item that's called loom tubing. So some people might have heard of loom tubing. Some people might have seen it and never known what it was. So loom tubing is flexible, convoluted protection and organization for cables in all kinds of different applications. It's split down the middle and it's just plastic tubing that goes around the cable. Again, meant for cable organization and additional protection.
I'm pretty sure I've seen that in cars.
Yeah. Oh, it's in cars. If you pop open the hood of your car, it's all over the place for battery connections, for data communications. It's just a good feature to include when extra protection of cables is required.
All right. Halogen free, that's a big one. And that's really important to understand what halogen free means because there's some rather nasty halogens.
Yeah, that's right. So a jacket material labeled as halogen free doesn't use hazardous and toxic chemicals such as chlorine, fluorine, bromine, iodine, or astatine, which are all halogens, in the cable insulation or jacket material. And it won't release the associated toxic chemicals when a cable might be exposed to fire or flames.
Yeah, and I think particularly our listeners know this, when you get chlorine and hydrogen together, something rather nasty happens. That's hydrogen chloride, which is an acid, a very strong acid, and you do not want to breathe that one in.
Right, that's very right. There's some serious health and environmental hazards that are associated with the use of halogens. They're burning or when vapors are mixed or leached into water or other materials. These halogen-free cables are required for certain applications that need additional flame protection due to the flame retardants of halogens used. So PVC contains a halogen. You can tell a halogen is inside a material based on the name. The chlorine, fluorine, bromine, PVC is polyvinyl chloride. So these materials sometimes need to have halogens, but It's very important to know that there are certain applications that do require cables and other materials, other components to be made of halogen-free materials.
Yep. Good. Now we come a little bit to another mechanical aspect of a cable or a connector.
Yeah, that's right. So there's a feature on our contact carrier called the mechanical detent. So it's effectively a catch at the end of the contact carrier of a connector that prevents motion until it's released. It effectively holds the cable in position and prevents vibration. It's a tiny little flange at the very end of the contact carrier.
Okay.
So, moving on to another uncommon term that most people might not know is what's called an FKM plastic. And so, an FKM plastic is a fluoroelastomer based polymer, also sometimes called fluorine rubber, that is very good for high temperature use. It's got great resistance to fluids, as well as chemicals, oils, alcohols, and it's the material we use in our captive seal.
And the captive seal is in fact an O-ring,
right,
inside of the connector.
That's right. So our captive seal and O-ring are sometimes commonly interchangeable. However, they do have some differences depending on who you're talking to. But to start, captive seal is typically an elastomer-based O-ring style protection for cylindrical housings. It's commonly embedded, recessed, or otherwise built into the part, where the cross-section remains the same under high pressure. So a captive seal O-ring under pressure will not change its cross-section. It's very resistant to that pressure. This provides long-lasting resistance to foreign substances with minimal warping, which is why we use that fluoroelastomer, which has other good properties, in our captive seals.
Mm-hmm. Mm-hmm. Let's get back to the pins for a second before we close this up. Pins are, in our case at least, and most commonly, fortunately, they're crimped to the cables, to the copper of the cable. Why is that done?
Yeah, that's right. Well, in order to make the connection easier to accomplish, you have to secure the pin to the metal wire. So in our case, we use what's called gas-tight crimp connectors. And the crimping of the pin to the conductors is done in two places. And when you do it in those two places, it allows for that gas-tight connection.
And why is it important that this connection is gas-tight?
So the gas-tight connection helps prevent from ingress of foreign substances, and it also helps specifically with corrosion prevention.
So what you're talking about is actually corrosion of the cable from the inside out, a place where you would never see it until it's too late.
Right. And so what the gas-tight crimp connectors allow is for no gas to get inside, effectively, just like you said, get inside of the cable and rot it from the inside out.
Yeah, very important. Okay, and last topic.
So we have what's called in our connectors an integrated fixed stop. So what this does, it prevents compression of the O-ring and over-tightening of the nut. It's located under the O-ring, and it's rated for a certain torque spec so that when you torque the nut down, it will stop at a certain value and not allow it to be
squished.
Very
pushed
good.
Out of way, pushed out of position.
Thus compromising the effectiveness of the seal of the O-ring. So that's called the integrated fixed stop.
Wow. That was a long list. So usually, Theo, at this point, I give you a minute to think about your 5-word statement by summarizing, but this time there's no way. The only thing I can say is that when you look at a cordset, a connector from the outside, you see very little. You see the body.
Yeah.
But there is a tremendous amount of technology going on, and it's really in the best interest of our customers to understand the quality that goes into these cables, the level of detail, the little things we talk about, the little things we designed in to make these cables last for a very, very long time. And so it's not just that a cable is cheap. A cable has to be designed properly.
That's right. So
let's come to your 5-word statement then.
Yeah, thank you so much. So my 5-word phrase for summarizing this segment is understanding cable terminology is easy. And I know some of that stuff might have sounded complex, but the idea is that if you don't know what something means, you should look it up. You should ask someone. Right.
Give us a call.
Give us a call, start a conversation, and always strive to become more knowledgeable about this technology and this industry so that it can add value to your interactions.
Yeah, because cables that fail are a problem.
That's right. And we always want to be plugged in.
Yeah, very good. Thank you very much, Theo. This was a long one, but I hope it was valuable, and we'll see you next time. Bye-bye.
Thanks. Bye.
We hope you enjoyed this episode of Pepperl+Fuchs Plugged In. Please subscribe to our channel and never miss hearing about the latest innovations in factory automation.